let us move on to hopefully the final video, but we'll see. Most likely it is. Let's do 111. Exponents. Logarithms or exponents are equal to exponents. They are the same. Okay. Nice little rule. If you have a base and your exponent is a log of that same base, what's going to happen is they pretty much undo each other. Again, because logarithms are equal to exponents, it's like you're taking like the exponent of a log of that exponent, 5. So number 13, the answer is 16. Okay. I'll just show you why that is, because I'll show you guys how to set up 114, but really there's like a small shortcut to this, okay? You do want to change this into exponential form because they're both right now logs. So you can take 17. Your exponent is this. Log of base 7, 5 minus 2p. Oh, sorry, is equal to your argument, negative 3p minus 7. Okay. So then, since you have 17 to the log of base 17, they undo each other. And now you just have 5 minus 2p is equal to negative 3p minus 7. If you want to do a shortcut, really, it's pretty much the same thing as exponents. On exponents, if they have the same base, you just set up the exponents. On the logs, if they have the same base, you set the arguments equal to each other. So really, that's just what it is. They have the same base, you set the arguments equal to each other, and then you solve for that. You definitely need to check back your work because sometimes we might have to reject or accept because we're trying to make sure that these two over here are not 0 or negative. Let's just solve a couple, 1 or 2. So plus 3p. This is going to be 5 plus p is equal to negative 7. We're going to subtract 5 on both sides. P is equal to negative 12. Let's just check to make sure that this is not going to be a negative. Okay, log of 17, negative 3 times negative 12 minus 7. So this is going to be 36 minus 7. Okay, good. It's positive. It's positive in the inside. That's okay. All right. And then I think negative 12 will also work over here too as well because negative 2 times negative 12 is positive 24. So 24 plus 5, so that will be positive. Okay. All right. And just so that, like, you know, I'm not, like, lying to you or anything. So, you know, go ahead and check it out, you know. Like, so that can work, but as soon as we have 0, that does not work. As soon as we have, I don't know, negative 98, that's also an error too as well. Okay, so we just need to have positive numbers inside the logarithm. Let's do 115. Okay. Let's just do that, not really shortcut, but really they have the same base. So let's just set the arguments equal to each other. Okay, well, I'm going to add v on this side. I don't know why. I just want to, sometimes I put the variables on the left, sometimes I put on the right. I think I just want this positive, that's fine. And we're going to add 2 on both sides. 2v is equal to negative 4. Divide by 2. V is equal to negative 2. Let's go and check. Okay, so if we plug in negative 2 over here, so log of 9, negative, and then negative 2 minus 6. Ooh, I think this is going to be a no, because if we do that, this is still going to be 2 minus 6, and that's going to be negative 4. We cannot have a negative inside. Okay, negative. Negative inside, none. So we're just going to reject this, and there's going to be no solutions to this. So please be careful. You have to check. Okay, must check. You cannot have a 0 or a negative in the logarithm. So that will be that. Okay. I think, you know, the previous reviews we've just done E, and I've just kind of just told you it's an irrational number, but I'm not too sure if your other previous teachers have told you where it's gotten from. So before we do 118, if you really want to, on the back space, so I'm just trying to find some space over here, maybe this bottom part of the answer key. Okay, So e is an irrational number just like pi. So I want to kind of introduce pi again. So pi is really a ratio of your circumference of the circle divided by the diameter, okay? Circumference of a circle, and then the diameter. And then so if you keep dividing, again, circumference is like the perimeter, like how long it is around over the diameter, the length in between, you know, that line that passes through the center of the circle. So if you keep measuring any type of circle and get the circumference divided by diameter, you're going to get pi, or at least approximately. So this is where this irrational number pi is coming from. Where e is coming from is this one. Here's one way e is coming from. This equation is used for compound interest, like, you know, sometimes with the banks and like that. And actually, so this is pronounced Euler, you know, like oil. Okay. What I'm going to do is I'm going to put this in the y1 equals, and we're just going to keep plugging in numbers. So it'll be 1 plus 1 over x to the x power. Okay. So I'm going to quit that, and let's just see what happens when we just keep plugging in larger and larger numbers. So I'm just going to type in, let's type in 10. Okay, so we got 2.59. All right, that's okay. Let's type in 100, 2.704. Okay. Now let's type in 1,000, 2.716, and we're just going to keep getting bigger and bigger. 10,000, 2.718, and now it's really getting into, it's zoning in on E already. Okay, so the bigger number we keep plugging in for these two, the same values, so n and n, it keeps going to the specific number 2.718, etc. Okay, and then I usually run that off to 2.72. So the larger it gets, as x goes to infinity, you know, we keep plugging in more and more and more numbers. Y is heading towards this specific number e, or e to the 1. Okay, so this is where e is coming from. E is used for exponential growth. E is used in a couple of equations that deals with banking. And I can probably show you that in a little bit later. Okay. All right. So this is where E is coming from. Let's now go solve some equations that involve E. Okay. Let's do 118. Solve this equation approximately. Okay. Let's divide both sides by 6 first. E to the n minus 4 is equal to, I'm going to leave it as 61 over 6. All right. Let's change this into log form. Okay. Log, what is our base? Our base is E. Our argument is 61 over 6 is equal to our exponent n minus 4. We are going to have a new definition right now. If you see log base E, this is the definition of natural log. Okay, or ln. Okay, so your ln, or your natural log button, is over here. So it's not 1n as I previously had thought in high school and college. Okay, so it is not 1n. This is ln. They just switched the letters. Yeah, I don't know why they switched the letters. Why it's not nl. You know, ln. I think they just want. You know what? We'll research that together. Okay, we'll do that. So anyway, anytime you see natural log base E, that is now going to be natural log. Add 4 on both sides. So n is going to equal to 4 plus natural log of 61 over 6. This is where now, if it had said exactly, we would have circled this. But since it's approximately, we're going to use the calculator and get the 3 decimals, if there are some decimals. 4 plus. Again, natural log is this button right below the log button. natural log of 61 over 6. Okay, so we're going to go 6.319. So n is equal to 6.319. And we're going to truncate that. Okay, well, anyway, let's just check to make sure that has worked. 6.319. Yeah, okay, yeah, yes. Okay, so that's how you're going to do that starting from 118. The only difference with 122 is just don't use a calculator afterwards, just box like that answer over there. Okay, all right. 126. Let's do 126. This time around, it's giving us the natural log. Let's add 9 on both sides. Natural log of x minus 2 is equal to negative 1. And then I'm going to change this by definition. Remember, natural log is log base what? It is log base e. We have the log by itself. It is now safe to change this back into exponential form. So our base is e. What is our exponent? To the negative 1 is equal to our argument x minus 2. Okay. I can change this to 1 over e is equal to x minus 2. I'm going to add 2 on both sides, and we should be good to go, really. X is equal to 2 plus 1 over e. I'm going to accept this. This is totally fine. You do not have to put this into one fraction. I think the answer key does that. So I guess if you want to put it as one fraction, this is going to be 2e over e plus 1 over e, 2e plus 1 over e. And I feel like the answer key has this. I will accept either one. Like, this is fine already, especially for AP Calculus. You don't have to put them into one fraction. Let's just check the answer key just to see what they have done. 126. Oh, yeah, they did put it as one fraction. This is okay. This is okay. Just stop there already. Okay. All right, let's do 129. 129. Minus 6. Negative 4 natural log of 2p minus 7 is equal to, I hope, 8. Okay. Divide both sides by negative 4. Natural log of 2p minus 7 is equal to negative 2. Okay, let's just change one thing by definition. Natural log is log base e. 2p minus 7 equals negative 2. Let's change this into exponential form now. Our base is e. To the negative 2 is our exponent, is equal to 2p minus 7. I'm going to change this into 1 over e squared is equal to 2p minus 7. Oh, this is going to get super, super messy. I mean, I'm not worried about, like, it's just that I feel like the answer key is going to just do it as one fraction. 7 plus 1 over e squared is equal to 2p, and then we're going to divide both sides by 2. Okay. I am going to accept this, and this is fine. Okay. But if you really want to match it up with the answer key, we're probably going to have to do this one first. If you really, really want to do it, this is going to be 7e squared over e squared. Because if we can't cross these out, it just leaves with 7. Okay, then that means this is going to be 7e squared plus 1 over e squared divide by 2. And then to divide by 2, then we just put the 2 on the denominator. So this is going to be 7e squared plus 1 over 2e squared. I mean, this is technically nicer, but this is going to be fine for AP Calculus as well. I just want to check. 129, 129, yeah, 129. Okay. Last one for me, and after doing 142, I think you'll have enough information to really just do this exponents and logarithms review, and this should be enough for right now. Of course, we will review a little bit more when we get into more of the logs and natural logs along the calculus way. But let's just do 142, and that is it for me. Okay, We have the same log base because this is log base e, natural log. So what we're probably going to do is we're probably going to have to condense this into one log. So we can do natural log, and then we're going to use division because that is linked with the minus sign. So it's going to be x minus 1 over x minus 3 is equal to 2. I'm going to change natural log into log base e. I even put write small. I didn't even write small. So like, you know, these are like my cues, my teaching cues. Like, make sure to write small. I didn't even follow this. It's okay. So I'm going to try to write small from here on out, because it's going to be a lot of steps over here. X minus 1 over x minus 3. Okay, let's change this into exponential form. So this is going to be e squared is equal to x minus 1 over x minus 3. Remember, we're trying to solve for x. I don't like this denominator, so I just want to get rid of that one. I'm going to multiply both sides by x minus 3 and x minus 3. I think I'm going to distribute as well. Okay. So, remember, e squared is still a number, so I'm going to put that in front of the x. E squared x minus 3 e squared is equal to x minus 1. We're going to have to do a couple rearranging. What I mean by this is I'm going to put all the x's on one side and all the numbers on one side. So remember, this is a constant. This is still a number. So what I'm going to do is I'm going to add 3e squared so that I can put it on the right. And then at the same time, I'm going to minus x so that I can put this on the left. E squared x minus x is equal to 3e squared minus 1. And now I'm going to factor the x over here. X, e squared minus 1. Okay, so those x's are gone. Is equal to 3e squared minus 1. And then you're going to divide both sides by e squared minus 1. X equals 3e squared minus 1. E squared minus 1. Woo! This should do it. Let's just check. 142. They just have it backwards. Okay. This is totally negative on the top and totally negative on the bottom. Like negative meaning like these are just all of them have different signs, but it is the same thing. Okay. If you want to get that answer, they just multiplied everything on the top and bottom by -1 each. Okay, so, and that's why they have like that kind of flipped answer, but this is an equivalent. This should be it. This is enough information for you guys to finish the review. Thank you so much.